Also welcome from my side. So my part of the presentation will be optimization through stepwise planning, and I'm going to do it with some kind of example. So we will look at one example where we will look what will be the result with the default scheduling parameter, or what would be the result with just one step of scheduling. Talk a little bit about the structure of scheduling logic, so how you can create your own structure. And then in the last 3 chapters, we basically try to improve our scheduling logic so that we get from a good result to a better result and even better, so that in the end we have a great result. If it's the best result, it always depends on the user of it, but at least we have a kind of good result. So for our example, I will show you a little bit about the data, what we are using. So we have in the integrated master editor, we have 3 items. It will be A, B, and C, and they all have the same processes. They have painting, they have cutting, and they have inspection, just with a little bit of different times. They use all the same resources. And Inspection Center is actually a resource group, so it has 2 members, Inspection Center 1 and 2. But I need to say the resource evaluation is not such a big part of it today, so it will be more the sequence. Of course, usually it's important for the resource evaluation for Asprova to decide in which case, which machine, which tool, or whatever the kind of resource it is to choose from. But here today, it's really just about the sequence optimization. We have a specification table where we have the colors listed just for showing purpose. We have white, black, and we have some gray tones in between. Usually you have other colors like yellow or red and so on, but here just to make it easier visible in the resource Gantt chart later on, we have white, and then we will have black, and the colors in between are all gray. Of course, we have some orders that we want to schedule, and what you can see here in the order table, the color specification is on order level. So that means that item A is not always white, it's not always black, but it depends on the order which color it should have. And for the optimization, we want to have later, of course, the due date achievement, but we want to also reduce the setup time. And we have 2 setup tables. One is color specific for the paint job. So always, if we need to switch from a darker color to a lighter color, there will be 4 hours of setup. For the cutting process, there will be the setup based on the items. So we don't care about the color in that process. It depends on if we switch from item A to B or A to C and so on, we will require 2 hours. So that already means we need to have 2 different rules. One rule for the paint job, the color, but for the cutting, it is more item specific. And this is now what we will look with the default scheduling parameter. How will the result be, and why can we not get a good result or a great result? So you know the default scheduling parameter, it is just one level, and it has some commands like prepare for assignment, order explosion, some assignment commands, and some evaluation at the end. And we can do basically one setting here on the highest level. That means we can set one dispatching rule. We can set one setting forward, backward. Of course, there's the setting depending on the order, but overall, mostly just one setting per property. And this is the issue what we are having. We're having the dispatching rule. So the dispatching rule is Asprova takes all the orders, or basically takes all the operations, sorts them according to the dispatching rule, and then it will start with the first one, assign it, the second one, assign it, the third one, assign it. And in this one dispatching rule, we would need to map the rule. The due date should be met, but we would also like to have the color sequencing, but at the same time, at a different process, we want to optimize based on the item sequence. I know a way that we could have it here at least a little bit considered, but overall we won't have the good result, because what we are also missing here is the capacity. So this dispatching rule is set before assigning, so we don't know how will all our operations look at the resource Gantt chart, or how much capacity they will take. Resource evaluation I already talked about, so you can set different weights or write your own expressions, so Asprova can choose the best resource or the best resource combinations depending on main resource and sub resources. If we look at the resource Gantt chart with our data, what we are having, we can see on the first look, it looks okay because nothing is red. That means everything is on time. But of course, if we now look closer here at the paint shop, we see almost, or I think it's even every day, there will be one setup because we are switching from a darker color to a lighter color. At the cutting process, it's similar. Basically, every time we will need to have a setup. And yeah, last one where we have the issue is that the cutter is the longest process. So we can see at some time we will have some waiting time between the paint shop and the cutting. And all those rules we would need to try to bring into one dispatching rule or the backward scheduling, trying to bring it also into just one single parameter. And this is of course not so easy. If I want to bring the color in, I cannot bring it as first key, because then the paint shop would look great because it would be starting from light to dark without any setup. But of course, at the same time, the due dates will be messed up. If I bring the color as the second key, that means the color will be only sorted if we will have the same due date. So this, if we have some good orders, so if we have 10 orders with the same due date, we might get a good sequence, but overall it's more likely that this won't happen. So this is why we are saying a stepwise logic, where we do one assignment. Based on this assignment, we will try to improve the result again and again. Here in this example, I think we will do it 5 times to get a kind of good result. Just some evaluation. As I said, the due date achievement is good, but we see high lead time. And if we look here at the setup time for painting, almost 1/4 of the production time is used just for setup. Yeah, that's what I talked about. So we have just one dispatching rule. So the structuring the scheduling logic, there's of course no way that Asprova tells you how to do it. You can basically do as you would like to do it. I usually try to group them. So I have a preparation, initial assignment, optimization, evaluation. So later on, we will see it also. I can add some sub parameters again if I want to adjust my logic. It's of course easier to read it instead if 40-50 commands are written one after each other. So preparation, order explosion, or assignment of results. Initial assignment, this will be our first overall assignment. So we will assign all the operations based on one or more main keys. This will be the due date, because overall we would like to have the due date achievement. So here we will assign everything based on the due date. And then we have the optimization for paint shop, cutting, and inspection center. So we can always, at the paint shop, we can look at the result from the initial assignment. At the cutting, we can look at the result from the previous process. Yeah, so here at first, we will have 4 parameters for assigning. And as last, the evaluation of the parameter. So the default one, maybe additional ones. And another advantage, of course, of structuring it is to have the message window. So the output of the message matches the scheduling structure. So I can see which subparameter takes how long, has this subparameter some errors or warnings, so I can go into it and directly look what's the issue, what can I do about it. And yes, here we are having multiple dispatching rules. We will see it in the next screenshot. So again, depending on the area or whatever kind of operations I want to group, I can set individual dispatching rules and of course also other settings like assignment direction, resource evaluation, and so on. So we will start with the paint job optimization. And here, like I said, the scheduling parameter. So we can see we have here the dispatching rule, here we have another one, here another one, and here one. And over the first one assigns everything, and then the next one just reassigns the paint job, the next one just reassigns the cutting, and the last one reassigns the inspection center. And as the paint job, we can refer to the initial assignment. So we already have some kind of result, and now we can look at this result and try to resequence it after some rule. And of course, the important thing at the paint job is the color sequence. So this should be, of course, a key. As I said earlier, as a first key wouldn't be the right one. So here I have it as a second key, and the first key is the start time rounded to 3 days. So this basically means that from the initial assignment, we look at the paint job and start with the 7th to 9th February, group them into one group, and then the next 3 days, the next 3 days, and in between those groups, we will resort based on the color. I will show you how it will look. So this is after initial assignment. We saw it earlier from the default scheduling parameter. Here are the colors grouped. So we can see we are having here a few groups, and they will keep their sequence. So group 1, group 2, group 3, and so on. But in between the groups itself, we will then resequence according to the color. And after paint job optimization, this is how it will look. So from light to dark, and then we will restart again. So there will be, of course, some setup time in between, which is of course required, because otherwise we would just produce from light to dark for, I don't know, 2 weeks. And yeah, there is of course then the issue with the due date. I just decided 3 days. It's of course based up on the customer. Should it be 4 days, 5 days? But there can be, of course, also different rules. So we could say the second time we will have white. We want to restart a group. And by just using this small adjustment, we can see we have still the due date achievement, but we already reduced the setup from the paint shop from 5 days to 1.17 days. So it was just basically the initial assignment and just 2 dispatching keys to get this better result, what we are having here. And it is called stepwise because we are doing the initial assignment, and at the paint shop, the second assignment, which is then referring to the initial assignment. And as we are referring to some kind of assignment, we can actually look at the capacity, how it was used. As you saw, I said start time from the last assignment grouped by 3 days. Similar thing we're going to do with the cutting process. So we could see if we would now execute the whole logic, the result is now better because the cutting was still adjusted to the paint job, but there were always some cases where we are having C, item B, then back to item C, or twice item A, item C, back to item A. And this we would like to reduce. And this time we are not looking at the assignment from the previous run of the cutting, because we had the initial assignment, we had the paint job optimization, and if I would now look at the result of the cutting, this would be messed up because we were already rescheduling the paint job. So that's why we are basically looking at the output of the paint job. In this case, the total calculated EST, so the earliest possible start time, will be, in this case, rounded to 2 days. So we will take 2 days of group. In between those groups, there will be the item code. So it will be always item A, B, C. And if it's then still, we are still having twice the item A or twice the item B or more times, we would like to schedule them. The one that's required or can start first should be scheduled first. So as I said, if we look at the result after paint job, we can see we are having here some kind of issues. So this one is blue. This one actually starts too early. This one, there will be some which start too late. And that's why we are looking at the paint job, like I said, the 2 days of the paint job. And we can again see the coloring of the groups here. So at the moment, they are not next to each other, the members of one group, but after reassignment, we will have again group 1, group 2, group 3, and so on. And in between the group, the sequence will always be A, B, C, A, B, C. Of course, there can be groups where A, B, or C is not part of it, like we can see here, where we're just having B and C as one group. The issue what we are having here is, of course, we are saying the sequence should always be A, B, C, which is of course not the best sequence. So we would like to do it now more dynamically, so that group 1 could be ACB and group 2 could be BAC. And this we want to calculate based on the earliest start time of the group. So for example, if we look at the paint job, we can see the sequences A, C, B, C, and so on. So this time A, C, B would be the better result. And this we're gonna do by storing a value in a custom property. And as I said, because we structured the scheduling logic like that, I know I need to go to optimization, to cutter, and before the assignment of cutter, I need to fill this property, which is the earliest item demand. And as I said, if we look at the operation table, we will look at item A in the first group, and we will look at the first EST and we'll write it into the properties of all item A's of group 1. The same we're going to do with group B, group 2, and group 3, and of course with item A, B, and C. So with this one, we will get for group 1 the sequence ACB, but for group 2 we get the sequence BAC, and other groups could be, of course, look different. This one we could just use as a first key, and then as the next one we will still use the total calculated EST. I don't need to refer now to the grouping anymore because this was done already in the property. So the earliest item demand is of course based on the groups. So that's why I was able to remove the total calculated EST group to 2 days, but of course also the item sequence could be removed. And if we look at the previous result, and if we look at the previous result, what I hadn't said was, of course, here, because we were always saying ABC, there could be sometimes some gaps. And of course, if we will have a dynamic sequence, this gap now here is filled because we are now saying A, then C, and this one can start earlier than B before. And with this one, we also have a good result at the cutting process. For the inspection center, we won't do any optimization. We will just assign it based on what could what we can start first, and resource evaluation, as I said, we don't look so much into it. So here we just said take the resource which can be used first. Of course, if we look at it here, maybe we could have said this B should be going up here. So if it is possible to keep the item, maybe it's better to keep it like that. But in this example, we don't look at the inspection center. We will just schedule it. What can start, should start, and where it can start earlier, please use this resource. So now with this one, we have also reduced the setup from 4.83 days to 1.75 days. You can see from the earlier result and this result, version 2 was the ABC sequence, version 3 is now the dynamic sequence. So overall, we reduced the setup time and we are quite happy with this result. The only thing, if we look at the lead time, we are still having high lead time and high waiting time. So this is what we want to reduce as a last step. And yeah, just a few more words. So if we look at the output of the paint job, we can see the inventory gets quite high. And yes, it is because we are doing just a simple forward scheduling and we would like to now do a backward scheduling. I will add an adjustment parameter because I'm not doing any optimization. I just want to keep the paint job as it is, the sequence, and just want to reassign it backward because I don't want to have the sequence changed again. Otherwise, it could be that there will be some setup again. And yeah, again, dispatching rule, previous end time, descending, assignment direction backward, and dispatching rule absolute yes. So that's what I said with I want to keep the sequence. If I would have said no or nothing, it could be that Asprova will fill the gaps, which might be good. But of course, if I fill the gaps, this could result again in setup time. And yeah, the filter is of course just for the paint job because I just want to reassign the paint job. So after optimization, so before backward scheduling and after backward scheduling, as I said, the sequence will be kept and it will move as much as possible to the right. It will result in some gaps, but this is what we wanted to have. And if we look at the inventory fluctuation previously, and now we can see the WIP, work in progress, has been reduced as much as possible in this case. And the evaluation has now the lead time reduced to 2.55 days. So over the half has been reduced, and the wait time from 1.82 days to 0.51 days. And this is an overall good result. So we have a good lead time, we have less waiting time, setup time is okay, and this is we are happy with this result. And this was only possible, that's what I said, this was only possible by using the stepwise approach. So having our first sequence, then we were optimizing the paint job based on the initial sequence. We were optimizing the cutting based on the paint job. And inspection, here I'm just writing reassign because we're not really doing any optimization, but we were reassigning based on the cutting. And as a last assignment, we were reducing the lead time by again reassigning the paint job. So in total, the paint job had been assigned 3 times, the cutting 2 times, and the inspection also 2 times. So, and this was my presentation. So it was, like I said, an example, and I hope that you could follow it. I know it will a lot of slides.
Thank you very much, Stefan. Yes, we have a few questions. So first question is, how typical is it for an end user to modify the scheduling parameter. Is this something that you think an end user should be capable of doing, or what are your thoughts on that?
I guess we have all the different areas in that regard. So we have customers, of course, they don't want to do it. Basically, you could say they just want to click the button and whatever is set up there, they just believe in Asprova, that Asprova gives the good result. So if they should know it, I mean, it's of course to at least somehow follow what is happening. And of course, in some cases, if you have the optimization based on one process and you would like to have it in another process, there are of course ways to say, I copy this parameter, I paste it, I change just the filter, I change the dispatching key. So it's of course a question. If the customer can do it, it's great. If they are required to do it, I would say no.
Okay, thank you. Yeah, I think that makes a lot of sense. And I have another one. Let's see if that is something that can easily be answered or not, which is about the resource allocation of operations if you have a set of parallel machines. What can you do to, yeah, I guess the question is you have two machines that are the same or the similar, and how do you make sure that both of these machines have a good schedule?
Mm-hmm. Yeah, so basically that was what I said. I don't show that much today. It is of course the question at some point, because you have the possibility to say, do a resource evaluation or don't do it, so that we don't switch the resource all the time. So if I would have some optimization in this inspection center, I could say, okay, now after initial assignment, I assigned operations here, I assigned operations there, and I will keep them on the resource and I will just sequence it. It could be, of course, that if I would take one operation down there, this could lead to a better result. Yeah, I guess it's a little bit how the result should be. For example, if we look at this one, I guess it would be here, item B. This one could move up instead. So we could say maybe it's better if the inspection center is running B and there's B coming again, that it will stay on this one.
Okay, thank you. And we have one last question about something that you didn't specifically touch upon, but I think that is still very important, which is while a scheduling parameter is running, does the value of virtual properties update? Right, so if you, for example, in some step, I guess the assignment changes and you have a virtual property that is based upon that. If I then look at this virtual property, does it change while I'm scheduling?
It depends, I guess, where it is used. So if it's used as a dispatching rule, then of course not, because it is this order is done before the assignment. But yeah, if it's, I don't know, used in the resource evaluation or wherever, as far as I know, they should be updated.